Let me start with a simple question. Have you ever been asked to validate a method that you secretly knew was not fully ready? Maybe the peaks were not properly resolved. Maybe the retention time kept shifting. Or maybe system suitability was failing randomly. Yet, validation was expected to proceed. This situation highlights one of the most important and most misunderstood topics in analytical science: method development versus method validation. Which comes first? And why does the order matter so much? Let's explore this step by step. This topic is not just theoretical, it has real-world consequences. One of the biggest problems labs face is validation failure. When unstable or poorly developed methods are validated, the results lack reproducibility. Precision fails, accuracy fails, and the entire validation collapses. This leads to regulatory rejection. Agencies like the FDA expect scientifically sound and reliable methods. If the method itself is weak, the submission is rejected. And most importantly, valuable time and resources are wasted. Sometimes, months of work must be repeated. All of this happens simply because development was not done properly. Method development is the foundation of the entire analytical process. This is where the method is created. You carefully select the column. You optimize the mobile phase composition. You adjust flow rate, temperature, and wavelength. Your goal is to achieve sharp peaks and proper separation. Sample preparation is also critical. Extraction, filtration, and preparation must protect analyte integrity. Every parameter is optimized because the ultimate goal is reliability. A properly developed method must work consistently. Not once, not twice, but every single time. Once the method is developed, validation begins. Validation is the scientific proof. It demonstrates that the method is suitable for its intended purpose. According to ICHQ-2 guidelines, validation evaluates several key parameters: accuracy, precision, specificity, linearity, robustness, and range. Each of these confirms the method's performance. Validation is what regulatory agencies trust. It is the official evidence that your method is reliable and acceptable. This brings us to the golden rule of analytical science. No development means no validation. Validation cannot fix a bad method. Validation can only confirm a good one. If peaks are not resolved, validation will fail. If retention times are inconsistent, validation will fail. If system suitability fails, validation will fail. That is why development must always come first. Validation must always come second. This order must never be reversed. Let's look at a real-life example. A laboratory developed an impurity method, but the resolution between peaks was only 1.2. Ideally, resolution should be above 2. Despite this, validation was started. During validation, accuracy failed. Specificity failed. The method could not distinguish properly between peaks. The result: 2 months of work were lost, and the regulatory submission was delayed. This situation could have been avoided by improving development first. So how do you know when development is complete? There are clear scientific indicators. First, resolution between critical peaks should be greater than 2. Second, peak tailing should be controlled, ideally between 0.9 and 1.5. Third, retention times should be consistent. The variation should be minimal, with RSD less than or equal to 1%. And finally, system suitability should pass every single run. If all these conditions are met, Your method is ready for validation. In the pharmaceutical industry, the workflow always follows a logical sequence. Step 1 is development. This is where the method is designed. Step 2 is optimization. This is where the method is fine-tuned for best performance. Step 3 is validation. This is the formal proof of reliability. And finally, step 4 is routine use, where the validated method is used for daily testing. Following this workflow ensures quality, compliance, and efficiency. One of the biggest reasons for validation failure is deadline pressure. When timelines are tight, development is often rushed. But this dramatically increases the risk of failure. Studies and industry experience show that investing time in development reduces validation risk significantly. In fact, proper development makes validation almost effortless. When development is strong, validation becomes smooth and successful. Rushing development always creates problems later. Let's conclude with the most important message. Method development creates the method. Method validation proves the method works. Both are essential, but the order is critical. Always develop first. Always validate second. Never reverse the order. Because quality cannot be tested into a method. Quality must be built into the method from the very beginning. That is the key to scientific and regulatory success.